Hello everyone, in this AV we would be discussing about the 9th chapter of your textbook, that is current electricity. In today's world, it's very difficult to imagine a life without the electric current, or in general words we say simply current. So we will try to know in brief how the current works, what is a circuit, and how do we define current and all. We will also come to know about the Ohms law, and we would be solving few numericals. Now we have to start with two different types of current. One is known as the direct current, or in short we call it DC, and the other type of current is the alternating current, which we abbreviate as AC. Now the cells that we use for our torchlight is a source of DC current. Now what is a DC current? As you can see the definition, a direct current or a DC is a current of constant magnitude flowing in one direction. What we mean by this is, if we have to understand, then this is how it looks like. It goes in one flow and the magnitude is the same. This is for DC. Now if we talk about AC currents, then after every half cycle the phase changes. This is the positive half cycle and this is the negative half cycle. Then it will continue like this only. So after every half cycle the phase changes for AC current. Now you can see here, with the help of a wire, a bulb is connected to a battery, and from the positive terminal of the battery the current passes through the bulb glows, and finally it goes back to the negative terminal. This is what is happening inside a torch. So basically what happens inside a cell is, it converts the chemical energy, or there are chemical reactions taking place inside a cell where the chemical energy gets converted into electrical energy. We have two different rods. Basically they are known as electrodes. One is a positive electrode and the other one is negative electrode, and it is kept in a solution which is known as electrolytic solution. And then the two conducting rods are the anode and the cathode. In a cell, please remember that the ions are the charge carriers. Now there are two different kinds of cells. One is the primary cell and the other one is the secondary cells. We will try to know their differences, or the differences between them. Now primary cells are basically those cells in which we have irreversible chemical reactions taking place. You can see here the table tells us about the difference between the primary and secondary cells. So basically the chemical reaction is irreversible in primary cells, and this is the reason why it cannot be recharged. Once it cannot be recharged, that means it is basically a use and throw type of cell. It offers very high internal resistance and it gives very weak current. Now on the contrary, the secondary cells, the chemical reaction is reversible. Just because the chemical reactions are reversible, that means it can be recharged and it can be used again and again. This is one of the reasons why the primary cell is cheap and the secondary cell is high cost. Now since it can be recharged, it has the reversible chemical reaction taking place inside it. Now its internal resistance is low and it provides comparatively higher current than the primary cell. These are some of the differences between the primary and the secondary cells. Now we will try and understand the definition of electric current. Whenever we rub two bodies we see that the bodies, they get charged. How it happens? Because we know that there is a transfer of charge from one body to another body. So basically the rate at which the charge is transferred, this is known as the current. In proper words, current is the rate of flow of charge across the cross section normal to the direction of flow of current. Now if we assume that Q amount of charge passes through the cross section of a conductor in time small t, then the definition or the formula for current is current, which is denoted as capital I, is equal to charge per unit time. So formula becomes current is equal to charge upon time. Please remember that the current is a scalar quantity. We will also come to know that current has a direction. Still it's a scalar quantity because it does not obey the vector rules. That is not in the syllabus, so we are not talking about it here. Now current is a scalar quantity, and the charge, how do we find charge, is based on the number of electrons that are flowing multiplied by the charge on the electron. The charge on the electron is denoted as E, given as 1.6 into 10 raised to the power minus 19 coulomb. Coulomb is the SI unit of charge. So total charge can be calculated as Q is equal to N multiplied by E. N is the number of electrons that pass through the cross section, and E is the charge on one electron. It's given here. E is equal to 1.6 into 10 raised to the power minus 19 coulomb. Now to understand the direction of current and both conventional and electronic, we will simply know that the current will flow from positive terminal to the negative terminal. The SI unit of current is ampere. If we write from the equation I is equal to Q upon T, if we write this equation in terms of their SI unit, then 1 ampere is equal to 1 coulomb upon 1 second. Now another units of current is milliampere and microampere, but in class 9 we would be dealing only with amperes only. Now there are different types of symbols for the instruments that are being used in the circuit. We will see them one by one. For the source of current, as I told you that there are two types of current. One is the DC and the other one is AC. So for DC we have the batteries and the cells, so which are represented as two lines. One is a longer one and the other one is the shorter one. This represents a cell. Now the longer line represents the positive terminal and the shorter line represents the negative terminal. When you have more than one cell, or when you combine the cells, it becomes a battery. Again here this is the symbolic representation of the battery. The longer lines represent the positive terminal and the shorter lines represent the negative terminal. These two, they represent the source of DC current or direct current, and this is how we represent the alternating source or alternating current source. Next is the key. These are the representation of key, different representation of the key. This is when the key is open and this is when the key is closed. Here they have put a dot. Here the lines have been joined between the knots. Here also the jockey or the tapping key is joined to the next terminal. Then we have the resistance. Now what is a resistance we will see in the next portion. As of now For simple resistance, this is the representation, and this will have a fixed resistance value. For different resistance or variable resistance, we have this written RH, which is a rheostat. This is a rheostat. You see, this is the jockey which can slide over this point C. If you slide it towards the left, then the resistance decreases, and if you slide it towards the right, then the resistance increases. So we simply draw the symbol of resistance and we write RH, that is for rheostat or variable resistance. Now next is the ammeter. Ammeter is a very important element of the circuit. You can check here. This is how it's represented. Ammeter is an instrument which generally or which is used to measure the magnitude of the current flowing in the circuit. What other things we have to know? It will measure the current flowing through the circuit, and it is always connected or always joined in series. Now, what is a series and a parallel connection? If the same amount of current flows through the elements, then they are known as to be joined in series. If I have, let's say, a resistance, a bulb, and they are both connected this way, then we will term them to be connected in series. The same amount of current will flow through both of them. Now when we talk about voltmeter, this is the representation of voltmeter. This is an instrument which measures the potential difference or voltage. Its symbol is V, and it is always connected in parallel in a circuit. What do we mean by parallel? Like here in this case, if I want to measure the current, I will put ammeter somewhere here or here, but in series. But the voltmeter will be connected in parallel. So at this junction, the current will divide itself into two. Some amount of current will flow through this and some will pass through this. So this type of connection is known as the parallel connection. Now galvanometer is represented as this. This can be used to detect the presence of very small or very weak current. Then we have the load. Any appliance that is connected in a circuit is known as the load. Now we have connecting wires, which are represented generally as lines. Now let's look at some simple electronic circuits. For example, this one. Here all are connected in series. We can see that there is a cell. This is the positive terminal, this is the negative terminal. The current flows from the positive terminal, enters the resistance or the load or the bulb, and passes through the switch, goes to the negative terminal. This is a simple circuit. Now here we have many things in the circuit. Like for example, we have the bulb or the load, we have the voltmeter, we have the rheostat, we have the key, we have the cell, we have the ammeter. Now the ammeter and voltmeter, both the devices have two different keys. One is for the positive terminal marked in red, and the other one marked in black is for the negative terminal. So positive has to be connected to the positive and negative has to be connected to the negative terminal. Now, as we can see, the current starts flowing from the positive terminal of the cell, passes through ammeter, which will take the reading for current, and goes to the load or the bulb, and the voltmeter is connected in parallel. Then passing through the rheostat, we have a key, and back to the negative terminal. This is a complete electrical circuit. Now, if we have to see what will happen if we increase or decrease the resistance, then as I told you that rheostat, if you slide the jockey towards the left, the resistance decreases. Once the resistance decreases, the reading in the ammeter and voltmeter will increase and the bulb will glow more. And if we slide the jockey towards the right of the rheostat, that means the resistance increases and these two will show a smaller reading and the bulb will not glow as much as when it was glowing when the resistance was low. Now, to understand what is a conductor and an insulator, let's take one example. If this wire breaks here and I put a small piece of wood, will the current flow? Your answer would be no. Why the current won't flow? Because there is an obstruction in the path of the current because of the presence of wood. So, based on this logic, we will define conductors and insulator. Here, the current will not flow because we have placed wood, and wood is an insulator. So, insulators are those substances which do not allow current to flow through them. Okay, and why they don't allow the currents to flow through them? As I told you when we were discussing the battery or the cell, that in a battery or a cell, the ions will be the charge carriers, but in conductors and insulators we have the free electrons which are the charge carriers. So in insulators we do not have free electrons, or we have very less free electrons. That is why they offer a very high resistance to current, and that is why they don't allow the passage of current through them. So those are known as insulators. For example, we have plastic, we have wood, we have paper, and many things. Then conductors are those substances which will allow the current to flow through them. Why will they allow the currents to flow through them? Because they have something called free electrons, which are also known as charge carriers. For example, in this circuit you have seen initially the current was flowing because we have wires, and wires are made up of conductors, generally metals, copper wires. Then another example of conductor is human body. Human body is a very good conductor of electric current. Now we try to understand what is a open and a closed circuit. Look at these three pictures. In this case, for the passage of current, there is no break in between. The wires are properly connected and we have only conductors. The wire is a conductor, that's why the bulb glows. So in this case, we have, this will be termed as a complete circuit or a closed circuit. Why closed circuit? Because we do not have any insulator in between. So for an electric circuit to be completed, each component of it must allow the passage of current through it. That is, it should be conducting. Then we say that it's a closed circuit. In the next case, you see please, here we find that the wire is broken. That is why the bulb doesn't glow. So here there's nothing, means there is air, and air is an insulator. It doesn't allow the current to pass through it. Then we say that the circuit is an open circuit. And in the third case, half part we have a metal wire and another half part is a thread. Again, thread doesn't allow the current to pass through them. So this will be termed as a open circuit. Now we try to understand what is potential difference and resistance. Please look at this figure. We see that there are two conductors, A and B. A is positively charged and conductor B is uncharged, and they are connected through a wire. Then we find that the electrons from conductor B will flow through the wire to conductor A, because conductor A is positively charged, and we know that unlike charges attract each other and like charges repel each other, and the charge will always flow from a conductor having higher concentration of electrons or the charge to the conductor having the lower concentration of electrons. So here we have higher concentration of positive ions, so the electrons will flow from conductor B to conductor A. How long will they flow? Till both these conductors have the equal concentration of electron. Now another example given in the textbook is, in this case, conductor A is negatively charged conductor and conductor B is uncharged conductor. So uncharged conductor, in this case, now the excess of electron is on conductor A. That is why when they are connected through a metal wire, the electrons from a higher concentration will flow through the wire to the region of lower concentration. So this will be the direction of flow of electrons from a negatively charged conductor to the uncharged conductors. Again, how long will this electron flow? Till we have the equal concentration of electrons on both the conductors. In the third case, now we have conductor A is negatively charged, conductor B is positively charged, and they are connected through the metal wire. Now we find that the electrons will flow from a region of higher concentration to the region of lower concentration. This is why they have shown the direction of flow of electrons from negatively charged conductor A to the positively charged conductor B. Now, from all these examples, it's clear that the flow of electrons between two conductors, if they are joined by a metal wire, will flow from a region of higher concentration, means the conductor on which we have the more negative charge or more electrons, to the conductor which has less of it. And how long will it flow? Till there are equal number of charges on both the conductor. So if somehow we can maintain this difference, then the charges will continue to flow, and this is what is done in an electric cell. Now in an electric cell, the excess of electron on one electrode and a deficit of electron on the other electrode are maintained by a chemical reaction within the cell, and this can be maintained for a long time. So an electric cell works as a source of electrons, and there is a continuous flow of electrons in the external circuit connected with the cell, and the direction is from cathode to anode. This is how the current flows in the electric cell. Now let's try to understand the direction of electric current. For that, let's look at this example. If a body is dropped from a certain height, let's say that at point A, then the body will go down to point B. Here, point A is at higher gravitational potential, and point B, that is on the Earth's surface, is at lower gravitational potential. Another example they have given in the book is two vessels are joined, and we have to see, or we can see, that the pressure is high at vessel A and there is a low pressure in vessel B. So the liquid or the fluid flows from the region of higher pressure to the region of lower pressure. Similarly, in this example where we have two bodies joined, body A is at high temperature, body B is at a lower temperature, then the direction of flow of heat is from high temperature to low temperature, that is from body A to body V. So similarly, when we have two conductors, one is having a very high amount of positive charge or it has a deficiency of electrons, and the other conductor, that is B, is having excess of electrons and it's highly negatively charged but has a deficiency of positive charge. Then we will try to understand, based on the previous example, what will be the flow of current and what will be the flow of electrons. A conductor having an excess of electrons is said to be at low potential or negative potential, and the one having a deficit of electron, that is conductor A, is said to be at a higher potential or a positive potential. So since we have more electrons present on the conductor B or excess of electrons on conductor B, then if we connect it through a metal wire, then the electrons will flow from B to A. So the arrow points from B to A, and this is the flow of electron, and the flow of current is the opposite of the flow of electrons. That is why we have to keep in mind that the direction of flow of conventional current is always opposite to the direction of electrons or the direction of flow of electrons. We know that the like charges repel and the unlike charges attract each other. So if we have to create the excess or deficiency of any charge at a place, then certainly some work has to be done in bringing the charge from one point to another point. Now this work done is termed as the potential difference. The definition is the potential difference between two conductors is equal to the work done in transferring a unit positive charge from one conductor to other conductor. So we have the formula V equal to W upon Q. V is the potential difference or symbolic representation of potential difference, W is the amount of work done, and Q is the charge which has been transferred. Potential difference is a scalar quantity. Its SI unit is volt, which is represented as capital V. So if we have two different conductors, then the definition or the formula changes to V1 minus V2 is equal to W by Q. And if we have only one conductor, then the formula remains as V equal to W upon Q. Now potential difference is a scalar quantity. I have already told you. Unit of potential difference is volt. So we will try to define volt, 1 volt. First what we do is we write this formula in terms of SI unit. So potential difference is 1 volt is equal to 1 joule upon 1 coulomb, or 1V is equal to 1J upon 1C. Potential difference between 2 points will be 1 volt when the work done is 1 joule for bringing 1 coulomb of charge from one point to another point. This definition is important. The potential difference between 2 points is said to be 1 volt if the work done in transferring 1 coulomb of charge from one point to another is 1 joule. Now we have been talking about electrical resistance for quite some time now. Let us understand what is electrical resistance. The definition says the obstruction or the resistance offered to the flow of current by a conductor is known as electrical resistance. Let's try to understand. I have already told you that the conductors have something called free electrons, which are the charge carriers. So what happens is, the positive charges are fixed and these free electrons are having a random motion in a conductor. Now once we apply a certain potential difference across this conductor, then what happens is, the electrons being negatively charged will be attracted towards the positive. The electrons being the negatively charged will be attracted towards the positive. So on the way, what happens is, these electrons, they collide with each other, and at times they also collide with the fixed positive charge. So after each collision, their speed reduces and they again accelerate towards this positive terminal. Now this process continues with the free electrons, and as a result, the electrons do not move in bulk with an increasing speed from one end to the other, but they go very slowly, or we say they drift towards the positive terminal. And this is how the wire offers resistance. This is the full mechanism of resistance inside a wire or a conductor. This brings us to the Ohm's law. Now Ohm's law states that if for a conductor I amount of current is flowing through it, then it will be directly proportional to the potential difference across the wire. So we write, as per the Ohm's law, that V is directly proportional to I. The potential difference is directly proportional to the current flowing through it. This is Ohm's law. Now we know it very well that if I have to remove this proportionality sign and bring in the equal to sign, then I have to introduce a constant, and in this case that constant is R. This R is a constant known as resistance. Now most of our numericals will be based on this formula, that is Ohm's law. So from here also we can define resistance. So my resistance is equal to V upon I. That is, resistance can also be defined as potential difference upon current. Now resistance is a scalar quantity that we have to keep in mind, and the SI unit of resistance is ohms, spelled as OHM, and this is the symbol. Now to define 1 ohm, this is the definition, and it's very important also. The resistance will be 1 ohm when we have 1 ampere of current flowing through a conductor and the potential difference across the ends of that conductor is 1 volt. So the resistance of a conductor is said to be 1 ohm if the current of 1 ampere flows through it when the potential difference across its end is 1 volt. Now the last part of this portion is the factors affecting the resistance of a conductor. Now there are 4 factors that affect the resistance of a conductor. First is the material of the wire. Now material of the wire affects the flow of current in a conductor directly. Good conductors, to understand this we have to come back to this thing, how we understood the resistance. The good conductor will have more number of free electrons, and that is why they will offer less resistance to the flow of current. That is why the material of the wire is important. If we have the material made up of some element which has more free electrons, then obviously it will allow more passage of current. The next one is the length of the wire. We have to remember that length of the wire is directly proportional to the resistance. So if the length increases, then automatically the length of the wire, if the length of the wire increases, then automatically the resistance of the wire will also increase. Then we have the area of cross section. This, in short, we can remember as R is equal to rho L by A. Rho is the density, L is the length, and A is the area of cross section. R is the resistance of the conductor or the material. So resistance is directly proportional to L. Longer the conducting material, greater will be the resistance, and resistance is inversely proportional to area of cross section. Another thing we have to remember, that is the fourth factor, resistance of a material is also dependent upon the temperature. How is it dependent? See, if the temperature increases, then these molecules will start vibrating more. They'll have more energy. More energy means they will collide more. Once they start colliding more, that means they will offer more resistance. That is why temperature is directly related with resistance also. Once the temperature increases, that means the collision inside the wire or the material will increase and it will offer more resistance. That's all in this AV. The last part we will discuss in the next video. Thank you.